welcome to my channel again. So today I'm going to start the lecture 3 of chapter 2 of class 12 physics. So in last two videos we have discussed what is potential, what is equipotential surface, and etc. So now today we'll be discussing these 3 points: potential energy of a single charge, potential energy of a system of two charges in an external field, potential energy of a dipole in an external field. And this first point, potential energy of a single charge, this is also we have to find out on in the presence of external field. Okay, so let's start the first topic, potential energy of a single charge in an external field. That point is missing in the description, so please add whenever you are taking the notes. So let's start. We are now concerned with the potential energy of a charge in an external field. Okay, so what is the case? Let me show you. Say we are having a charge over here which is in a particular field, external electric field, say E. So this is the external electric field at which we have to bring a charge. Say this is the point where we have to bring this plus q charge. Say this point is V. From infinity we have to bring this charge, or the charge may stay at this point. So we have to find out the potential energy gathered by this charge particle plus q as it is placed in the electric field E. Okay, so let's see how it will work. So we are now concerned with the potential energy of a charge in an external electric field. We assume that the charge q does not significantly affect the sources producing the external field. So whenever we are taking this charge, this q will not affect the source charge, because of which we are getting this electric field. Okay, otherwise we cannot consider this point. And again we have to note that we are interested in determining the potential energy of a given charge q, okay, in the external field. We are not interested in the potential energy of the sources producing the external electric field. तो यहाँ पे जो सोर्स चार्ज एक होगा इस इलेक्ट्रिक फील्ड को प्रोड्यूस करने के लिए कोई ना कोई चार्ज होगा, से दैट इज प्लस क्यू. उसके लिए कितना पोटेंशियल होगा वो फाइंड आउट करने के लिए हम इंटरेस्टेड नहीं है. वी आर ट्राइंग टू फोकस ऑन दिस चार्ज. ओके, this charge which is placed in an external electric field, we are mainly focused to find that out. Okay, now this is the case, and how will finding it out? The external electric field E corresponding external potential V may vary from point to point. So that means whenever we are having an external electric field over here, so at different points, say this is say point P, this is say Q, this is say R. At different points the value of potential will be different. Say this is Vp, this is Vq, and this is Vr. So these potentials will be different. So if we consider a coordinate system over here, and this is the radius vectors, say this is R1, this is R2, this is R3, then the potential will be the function of R. R is what? R is the radius vector. So you have to remember this. So now the work done in bringing a charge from infinity to a point P in the external field is QV. This work done is stored in the form of potential energy of Q. If the point P has position vector small r relative to some origin, we can write potential energy of Q at R in an external field is QVR. Okay, so let's say we are considering this coordinate system. Now if in this coordinate system we are having the electric field E, at every point we are having this electric field. So corresponding to that, say we are considering this point P where we have to find out the potential. Now if we have to bring a plus q charge from infinity to this point, so the work done which we have to do is this is simply q into V. Now this potential, as I told you, just as I told you that V will be function of R, so this potential will be also function of R. So this will be the work done at this point gathered, which is done by this plus q charge, and it will be gathered by this plus q charge as a potential energy of this single charge particle. Okay, so this is it. So this is the potential energy of a single charge at a particular external electric field. Now let's move on to the next slide, that is potential energy of a system of two charges in an external field. Now we have to consider two charges, right? So previously there was a single charge, we have to bring a single charge over here. Now we are considering two charges. So let's say again we are trying to have a particular coordinate system. Now we are choosing 2 points. Say this is P, say this is R1, say this is Q, this is R2. Okay, this is R2. Now we are considering two charges. Say this is Q1 and another charge is Q2. So we are trying to bring these two charges at this point and this point. Okay, now what will be the potential energy gathered by these two charges to take these 2 points? And let me also clarify, the length in between them is say R12. This length is R12. Okay, so this is the diagram which we have to consider. Now now if we try to find out what will be the potential for this case, we can simply write, say u for the first Q1 will be similar. We have to remember that there is a electric field over here, E, always it is there. We are trying to find out the potential energy of these two charges in an external electric field E. So because of this external electric field E, what will be the potential energy for this plus Q1 charge? It will be simply Q1 into VR1, right, as we have learned in the previous slide. Similarly, U2 will be what for this point? Q2 into VR2, right? Now a particular interaction will be also there in between these two charges, Q1 and Q2, and whenever they are placed at P and Q, they will interact through this line, right? They will interact through this line. So due to that, another term U3 will come, and it will be simply Q1 Q2 divided by K R12, right? It is very simple. So this 3 will be added up to give us the final result for this 3 will be giving us the final result for the total potential energy gathered by these two charges when they are placed at 2 points P and Q in an external electric field E vector. Okay, so this is how it is said. This epsilon will not be there, as you can see here. This epsilon will not be there, it is extra. This is error. So finally this is the notes you can take from here. And finally we had a particular extra point which will be trying to figure it out, the potential energy of a dipole in an external field. Let's move on to that. So for that we will be going to a different slide. Say, so let's see. So now we are trying to find out the potential energy of an electric dipole in an uniform electric field. So this potential energy will be coming from the work done on an electric dipole in an uniform electric field. So first we will be trying to find out when an electric dipole is at an uniform electric field, then what is the work what is done on that electric dipole? So it is like when an electric dipole is placed in a uniform electric field, it experiences torque and tends to align in such a way to attain stable equilibrium. Okay, so say this is the dipole and this is the external electric field. So whenever this electric field is applied, so there will be angular displacement, because this electric field will apply two forces QE on two different charges, right? So this will be displaced to this certain case, and say this displacement is d theta. So the angle was previously theta 1, and now it is displaced due to the presence of external electric field to d theta. So the final angle is theta 2. Now what is dW? The work done on this dipole, it is simply tau into d theta, because tau is what? Tau is simply the rotational analogous to force. हम क्या जानते हैं? W is equals to F into S. तो F क्या है? F लीनियर केस में F मतलब जो रोल प्ले करता है, सेम रोल टाउ प्ले करता है इन रोटेशन, ठीक है, रोटेशनल मैकेनिक्स में, और S जो रोल प्ले करता है, सेम रोल थीटा भी प्ले करता है इन रोटेशन. ऐसे अगर आप समझोगे तो ये इजी रह सकता है आप लोगों के लिए. सो दैट्स वाई dW is chosen as tau into d theta. Okay, tau into d theta. So let's see. So we have already calculated what is tau. So this is PE sin theta d theta. Tau is PE sin theta d theta. So dW जहाँ पे हम लोग मार्क कर रहे हैं PE sin theta d theta, right? So PE sin theta d theta. Next it was initially at PE sin theta d theta for a small displacement d theta. Now it is coming from theta 1 to theta 2. So that's why we are trying to find out the total work done. Okay. So whenever we are trying to find out total work done, we are just solving this integration, and how to solve it, let's see. It's very simple. फिर भी मैं आप लोग को एक बार बता देता हूँ. W is equals to integration PE sin theta d theta, theta 1 to theta 2, right? So PE बाहर चला आएगा. Now integration sin theta d theta, theta 1 to theta 2. So ये क्या हो जाएगा? P into E. sin theta का इंटीग्रेशन क्या है? cos theta, theta 1 to theta 2. So minus sin theta, sorry, minus cos theta, sorry, यहाँ पे एक माइनस होगा. So PE first of all minus cos theta 2 minus of minus cos theta 1, ठीक है. So that's why it will come like cos theta 1 minus cos theta 2. So this is the final work done for a particular dipole, which will be stored as the potential energy. Okay, so this is how it comes. Now we are considering that potential energy is arbitrarily taken 0 when the dipole is at 90 degree. Okay, then potential energy is rotating the dipole and inclining it at an angle theta. See, what is the case I am talking about? If the electric field is in this direction and the dipole will be, say, in this direction, say this is the direction of dipole, means this here is minus q, here is plus q. That's why the direction of P is like this. So in that case, what will be the direction of the angle? What is torque? Torque is P cross E, na? We already know this. So it is actually PE sin theta. So what is this theta? So this theta is actually from P to Q, P to E, always P to E. So this is always the direction. P क्रॉस E अगर होगा तो P to E होगा एंगल का डायरेक्शन. ठीक है. सो दिस इज द थीटा ओवर हियर, राइट. तो ये अगर थीटा है तो लेट्स सी, so we can write cos theta 2 as we can take cos theta 1 as 90 degree and theta 2 as theta, because this dipole is, I am talking about like this say this is the electric field and dipole was in this condition. See, so dipole was in this condition. P is like this. So this was theta 2 was 90 degree, but now we are trying to get this dipole from here to here, 90 to say theta, right, here to here. So now this is theta. So theta 1 was 90 degree and theta is at theta, theta 2 is as theta. So u is now minus PE cos theta, because it was at stable, this was the case where u was 0. Now it is coming at this this point because of the presence of this electric field. So that's why this will be the case of total potential energy. Now let's see 3 different cases. Potential energy can be taken 0 arbitrarily at any position of the dipole. So you can choose a different point also, that as per your choice. So case 1, if theta is equals to 0, u is equals to minus P into E. So that is, if theta is equals to 0 means what? Theta equals to 0 means if the electric field is in this direction and the dipole is also in this direction, so what is the angle in this case? 0 degree. So if you put this value minus PE cos 0 degree, you will be having only PE. So when dipole is aligned in this direction of electric field, or the dipole is parallel to the electric field, it is the stable case. Okay, stable case. So dipole will be not shifted after applying a force, a little bit force. Okay, but if theta is 90 degree, then potential is 0. Theta is 90 degree means the dipole is in this direction, say, and the external electric field is in this direction. So in that case only theta will be equals to 90 degree. So u will be equals to minus PE cos 90. So it will be only minus PE. U will be only minus PE. Clear? So this is the case. Sorry. I made a mistake. This will be the direction of P. This will be E. So this is 90 degree. Very sorry. So this will be PE cos 90. So cos 90 is 0. So u will be equals to 0. Very sorry. So now let's see the next point. If theta is equals to 180 degree, then u is equals to PE, right? U is equals to PE. So let's see what will be the case. Say this will be the direction of the external electric field, and the dipole, if it is aligned in this direction P, then the angle will be between dipole and external electric field, theta will be equals to 180 degree. So what will be u? Minus PE cos 180 degree. So this minus and the minus PE, and this is minus 1, so it will be plus P into E, but this is unstable. This is unstable. Unstable case. unstable case. Whenever the direction of dipole and the direction of electric field is opposite, this will be called as unstable case. Okay, so dipole will, after a certain amount of time or after giving a little bit force, it will be again aligned to the direction of electric field. That is the basic nature. So that's it. So I hope you